The first lesson of 10th class is real numbers. So I am going to start real numbers today. Real numbers, because you have been learning about the numbers right from class 4. Natural numbers, whole numbers, integers, rational numbers, irrational numbers, like that. We have been learning all these numbers right from 4th class. Okay. So now, real numbers. What are real numbers? So actually, as per the definition, इसमें definition पढ़ने की ज़रूरत नहीं है, because you have learned already. The definition is in 9th class. But still, I would like to tell you what are real numbers. Real means which are existing. Okay, where they are existing? They are existing on the number line. That means on the number line, if you are able to locate a number, on the number line, if you are able to find a number, then that is real. So what numbers you can find in different ways, you have already learned in the lower classes, right? So all natural numbers, we can represent it on the number line. All integers, we can represent it on the number line. Whole numbers on the number line we can find. Even the rational numbers, fractions, decimal numbers, all these things we can put it on the number line. Even in 9th class you have learned root 2. Root 2 is a irrational number. So irrational number also we located on the number line. So that means irrational numbers, rational numbers, all these numbers together we call them real numbers. Okay. So now in this class we will go a little ahead. Now we will learn some laws. So first law is Euclid division law. So all of you know what is a division law. Division law is nothing but it comes in the division. So when we divide something, okay, here some number will be there, and here we call this as a dividend. Okay, and here we will have one more number, so we will call divisor, and here you get one more number, we call it as quotient. Finally you will be getting a number remainder. So when you do division between two numbers, then divisor will be there on the left side, which you are going to divide a number. We call it as a divisor, and you get something quotient on the right side. So, and finally you will be getting remainder. Every two numbers, in between every two numbers, if you divide a number with a number, definitely all these things will exist. Okay. So now we will convert this into numbers. Okay. I gave you what are the names for all these things. I will just convert with these numbers. Okay. So now I am dividing a number with 10. I am dividing 10 with 3. So then what happens? 3 times 3, 9, 1. So now here, fortunately, quotient also is equal to 3. And divisor is also 3, and the dividend is 10, and the remainder is 1. This is a simple division. So the same division we are going to have the formula type. Okay. So this 10 is equal to, you multiply these two, that means divisor into quotient, 3 into 3, plus this remainder, plus 1. You take any division and you do this, it will get satisfied. 10 is equal to 3 is 9 plus 1, 10. So that means this dividend is equal to divisor into quotient plus remainder. This is a division rule. The same division rule Euclid gave with a general notation. What is the general notation? In the place of 10 and 3, he has taken A and B. So if I take A and B, okay, so I'll take B here, I'll take A here. So then we don't know, previously 10 and 3 were there, 10 is the greater number. Now B and A is there, B is the greater number. This dividend should be greater than the divisor. So now how many times it will go? We don't know. Let us say Q times. Q is resembling a quotient. Q times, and how much remainder is coming? R. You can have small r or you can have capital R also. I will write small r. So now when I want to change the division rule, what happens? So first I should write B is equal to quotient into divisor, that means divisor into quotient plus remainder. So this is nothing but Euclid division lemma, Euclid division rule. So in this there is a condition for B between B and A. What is the condition between B and A? B is greater than A. And AB are two integers. AB are two integers. And they are always positive integers. These are the general conditions for A and B. So B should be greater than A, and A and B are integers, and R should be equal to 0 or more than 0, because R should be greater than or equal to 0. Always. Remainder may be 0 or more than 0. So this is the condition for R and this is the condition for B. B is greater than A. So this is nothing but Euclid's division lemma. Okay, name is looking specific, unique, but very simple. Euclid division lemma is nothing but a division rule, a division algorithm. I hope you have understood. Let us go to the next concept.